So we're going to continue along in that packet of graphs of f, f prime, and f double prime. And I'd like you to take a moment and read number 11. What's the definition of f increasing? F should be increasing where f prime is positive. Well, you have a formula for f prime, and we're told this is a calculator question. I think looking at the answers, you could also tell it's a calculator question. So I'm going to go, and I'm going to graph my f prime. I'm going to type in sine x plus x cosine x, sine x plus x cosine x. I'm going to set my window. Well, actually, before I set the window, I'm dealing with trig, so I need to make sure I'm in radian mode. Oh, good, I'm in radian mode. I'm going to set my window so the x values go from 0 to pi. The y's, I don't know. Maybe -5 to 5. We'll count by ones. We'll adjust if we have to. Take a moment and go graph that. So this is not the graph of my function. This is the graph of f prime. That's f prime. And I want to know where f prime is positive. Since this is the graph of f prime and I want to know where f prime is positive, that means I'm looking for positive y values on f prime. So really, all of that stuff is good. I need to go do second calc and find the 0 over there. Well, you go do that. Second calc, find the 0. Looks like 2.028. No, sorry, 2.029 when we round to 3 places. Where is f prime positive? Between 0 and 2.029. If it was me, I would have probably written it with parentheses, but sometimes they'll put brackets on there because different textbooks sometimes use closed intervals rather than open intervals. The AP exam would never give you a problem like this and make you distinguish between parentheses or brackets for something like this, so don't worry about that. Read number 12 and see what you can do. Okay, well, for starters, I'm going to go graph that function, x cubed minus 3x plus 2. I'm going to make my window maybe -5 to 5, count by ones on both the x and the y. I think that's okay. And I'm getting a graph like this. This is the graph of f prime. I see that f prime is changing from positive to negative over here, which means that, sorry, I got that wrong. F prime is going from negative to positive over there, which means that f has a relative minimum at whatever x value that is. Doesn't look like anything's changing here, but sometimes they're sneaky. It might cross, but just a tiny little bit. Maybe I should zoom in a little bit on that part. I can change my window maybe to go from 0.5 to 1.5, from -1 up to +1, and see what happens there. 0.5 to 1.5, -1 to +1. Is it going to cross? No, it's just going to hit that x-axis. I guess I could find the 0 and find the minimum and make sure they agree, but I'm going to spare us the time. I know that they will. So there's nothing interesting happening there, and we're going to go with letter B for our answer. Next, number 13. See what you can do in number 13. It's a little different, but I think you can figure this out. I want to know where h is concave down, which means where h double prime is negative. I'm going to go graph that function, x to the 5th minus 3x squared plus x. I want to deal with this between -5 to 5, -5, 5, 1. If that's not good enough, I'll adjust. I think that'll work. And I need to know where the slope of h prime is negative, so really that part where I'm decreasing. I think I need to go and find my maximum and my minimum. think my maximum occurs about 0.167. Let me try to draw this out a little bit. That's 0.167. My minimum, I think, is occurring at, let's see here. My minimum's, oh, that's kind of nice. It's just occurring at 1. So I think h double prime is negative from there to there because that's where h prime has a negative slope. We're going to go with letter D for this one. Last one in this part. See if you can do number 14. So I'm going to go graph that function. I'm going to set my window so the x values are from -3 to 4. Maybe I'll stick with my -5 to 5 for the y's. I can't see every, well, actually, let's see. I want to know where g has a point of inflection, where g changes from concave up to concave down, which means I want g double prime to change from positive to negative, and I'm looking at the graph of g double prime. I think I'm talking about that point right over there, where the y values are changing from positive to negative. So I'm going to do second calc 0. Oops, I think I drew on my calculator. That's not good. I am thinking x equals 2.3, and I think that's the only place. I think g double prime is changing from negative to positive over there, so concave down to concave up, same over there. We're going to go with letter A. Oops, I guess letter D appeared on the next page. I've got to fix that for next year, but it wasn't D. Wonderful, it was letter A. Last problem we're going to look at. Free response question. And by the way, this topic is a big deal for the AP exam. We have to add a few more things to this before we're totally ready for an AP-style free response question. But I think we can get a lot of ideas of what they might ask out of this. Take a moment, read through this problem, and actually, I think you can probably do A and B. See if you can go do letter A, then we'll talk, then B, then we'll talk, and then we'll deal with C together. What's the answer to 15A? Okay, so points of inflection will occur where f double prime changes sign. So where the slope of f prime is changing sign. So I'm thinking x equals -1, 1, and 4. Because f double prime changes sign there. See what you can do for 15b. Relative minimum. Okay, so a relative minimum occurs where f prime is changing from negative to positive. I've got the graph of f prime here. F prime's changing from positive to negative, negative to negative. That's not interesting. Over here, I think we're going to go with x equals 6. Why? Because f prime changes from negative to positive there. Last one. We'll do this one together, at least part of it together. C, let h of x be the function defined by that formula. Find an equation for a line tangent to h at x equals 2. So tangent line, y minus y1 equals m times x minus x1. I know my x1's -2. I'm going to find my y1 by plugging -2 into my h function, and I'm going to find my m by plugging -2 into h prime. Well, as far as h of -2 is concerned, we're going to get h of -2 equals -2 squared times f of -2. Go figure that out and tell me what h of -2 is. H of -2 is going to be 4 times f of -2. I can't get that from the graph because this is the graph of f prime. Oh, but hold on, check this out. I'm telling you that f of -2 is a half. So we're going to do 4 times a half. There's a reason they told us that. 4 times a half, that's going to equal 2. Sure it is. For h prime, well, I need to go calculate a formula for h prime of x. And we need to go use the product rule for that. You know what? See if you can make your formula for h prime of x, and then see if you can tell me what h prime of negative 2 is. First, times derivative of the second, plus second, times derivative of the first. I'll go plug in my negative 2, and I'm going to get negative 2 squared times f prime of negative 2, plus 2 times negative 2 times f of negative 2. Okay, 4 times f prime of negative 2. Well, this was the graph of f prime, so I think f prime of negative 2 is just 0. Plus negative 4 times, I already know, because I told you over here, that f of negative 2 is a half. So I'm going to get negative 2 for that slope. So y minus 2 equals negative 2 times x minus negative 2x plus 2. A lot of 2's there, but that's what we'll end up with. And you'll see something similar-ish to this in the homework. This idea is a very big deal on the AP exam. They love questions where they give you graphs of either f or f prime or f double prime and ask you various things about increasing, decreasing, and all that. So definitely an important topic.